Let's pick up with where we left off. So here we have a mean salary for entry-level workers. That's $37,000. The standard deviation is 1,600. And so we're going to find the proportion, or the probability of people who have salaries within a particular range. So for less than 36,000, that means that 36,000 is going to be as high as it goes. So we're going to do second vars, do the normal CDF. We're going to do negative and then just really, really huge number. Let's see, the number we are interested in is 36,000. We then put in the mean, which they tell us is 37,000. That's the mu value. The standard deviation sigma, that's 1,600. So we go ahead and run that through. You get 0.2660 if you round that off. So 0.2660. Next, you want more than 38.5. So we'll do second vars. We're going to do the normal CDF. So that means 38,500 is the low end. And then we're going to go as high as we possibly can. So again, we'll just enter a really, really huge number here. The mean and standard deviation have not changed. That's giving you, looks like that rounds off to 1,743. Here they want between 36 and 38.5. So we'll do second vars, pick the normal CDF. 36,000 is the low end. 38,500 is the high end. Mean is 37,000. Standard deviation is 1,600. Work out what that jazz is. You get 0.5598. So 5598, roughly 56%. Between 55 and 39, or sorry, between 35 and 39. So you go second vars again, pick your normal CDF. What were the numbers? 35 to 39. So 35,000. Whoop, that's as high as 39,000. Same mean, same standard deviation. That's 0.7887. All right, so that's what this is. All right, what do we have next here? So next we want the 85th percentile. Again, same scenario here. So 85th percentile, that means we're interested in 0.85. That's going to be for the inverse normal. So we're going to do second vars, pick the inverse normal when they tell you a percentile, 0.85. 37,000 is the mean. 1,600 is the standard deviation. That's 38,658. So 38,658.29. So that is the amount of money that fits into that description. 95th percentile. So that's going to be 0.95 that we're going to use. So again, do second vars, pick inverse normal when you're looking for a percentile. This time we want 0.95 for 95th percentile. Mean and standard deviation are the same as they were before. 39631. Whoop, up here. 39631. And how much change is that? 77 if you round that off. So that would be the amount of money for that one. The middle 50%. All right, so the middle 50. So you got your bell curve here in the middle, in this big lump. You've got 50% of the data. Because the total is supposed to be 100%, that means that these two tails on top and on bottom comprise the other 50% of the data. You're going to divide that up equally so that this is 25% and this is 25% on each side. So then if you go from 0 up to 25, that means this one is 25%. And then if you start at 100 and back up 25, that's going to give you 75%. So we're going to do the inverse normal of 0.25 and 0.75 and find out what those are. Assuming the calculator decides to start working again. So we're going to pick the inverse normal function again. Let's see, we want the 25th percentile, 0.25. Let's see, the mean is 37,000. 1600 is the standard deviation. So we work out what that is. You get 35,920.82. So for 0.25, you get 35,920.82. And then for 0.75, let's see what that is. So again, do the inverse normal when you're dealing with a percentile. Change this to 0.75. Mean and standard deviation are already inputted in there. 38,079. So that's 38,079.18. Okay. So then I want the middle 90%. So again, the way you would figure this out, I think a picture is helpful for me to visualize what's going on. There's 90%. You're going to have, let's see, you're going to have 10% spread between the two tails. That means that 5% is down there, 5% is down there. So if you go from 0 at the bottom up to 5, that's your 5% mark. If you do 100% at the top and back up 5, that is 95%. And remember that 5% is the decimal 0.05. Please watch out for that. Don't tell me it's 0.5. That means 50. Let's see. So we're going to do inverse normal. I'm going to start with 0.05 for 5%. And what do we get? 34,368. So 34,368.23. That's the low end. And then for the high end, we'll do that all over again, once more with feeling. Let's see, so 95 is 0.95. Work that out, 39,631. 39,631.77. There you go. All right. Then there's something called the standard normal. And so this is where we assume the mean is just 0 and we have a standard deviation of 1. And so typically what is done in statistics is you kind of standardize things so that you can make a fair comparison to different sets of data where you might have a different mean and a different standard deviation. So for instance, if you were comparing, say, the heights of males and the heights of females, for instance, it would not be a fair comparison to go to compare female height data using like the male numbers as your frame of reference. So what you can do is what's called standardize the data. And you basically use this formula for what's called a z-score. And then what a z-score lets you do is it gives you kind of a fair apples to apples kind of comparison for two different sets of data that would have different means and different standard deviations. So assume that z follows a standard normal distribution and that x follows a normal distribution with mean 15, standard deviation equal to 3. So what we're going to do is find the probability when z is less than or equal to 1. So the first thing we need to do is find the z-score that's going to correspond with this. So the formula is you do x minus mu over sigma. So the x in this case is going to be 1, because that's the target value that we are interested in. So, and actually I'm getting ahead of myself. Here is where we go by x values, but we're actually not, we're not to this point yet. Here, we're just going to be doing a distribution based off of z. So what this means is we're going to do a normal CDF like we've done previously. So the lowest it can possibly go is -infinity. And then we've got to go up to and including 1. So 1's actually going to be the high end number. The mean is 0. The standard deviation is 1. So we're not using either of these numbers yet. So we're going to need to get our calculator and say, all right, calculator, find for me second vars, do a normal CDF. We're going to go negative, really huge number to stand in for infinity, up to 1. Mu is 0, mean is 1. If you work that out, you get 0.8413. So that will be our solution for this first one here, 0.8413. Next, they say find it for when z is greater than or equal to -2. So what that means is we're going to do the normal CDF. This time, we want to be bigger than -2. So -2 is as low as it's going to go. We're going to go up as high as we feel like to infinity. And we're still going to use 0 as the mean and 1 as the standard deviation. So if we do this, we're going to do second vars. Pick our trusty normal CDF again. -2 is the low end. An arbitrarily humongous number for the upper end. Keep 0 and 1 for the standard normal, which is z, 0.9772. So that's what this is going to be. So there's that. And they say find the 98th percentile of z. Well, that's just going to be the inverse normal. 98th percentile will be 0.98. You want the mean, which is 0. You want the standard deviation, which is 1. And so then you work out the inverse normal of that. Second vars. There's inverse normal. And you say the area is 0.98. 0 is the mu, 1 is the sigma. That's 2.054 if you round that off. So 2.054. So that would be the z value that would correspond to that. So then here, we're going to do z-scores. So this is the formula that I was mentioning earlier. So z is x minus mu over sigma. So here what we're going to do is we're going to calculate a z and say, all right, the x they give me is 18. The mu that I'm given is 15. And we're going to divide that by 3. That's going to work out to give you 3 over 3, which is equal to 1. Now you notice that's actually the same as this. That's not what I wanted to do. So this is actually the probability of z less than or equal to 1. So we've transformed x into being in terms of z. And we already found what this was. It was 0.8413. So 0.8413 is what that'll be. Here we're going to do something similar. So we've got z is, here's your x value, which is 9. You'd subtract 15 and then divide that by 3. 9 minus 15 is -6. And then divide that by 3, which is going to give you -2. So this is in fact giving you the probability of x greater than or equal, or sorry, not x, z. We turn the x into a z. Z greater than or equal to -2. Well, that should look familiar because that's actually this right here, which was 0.9772. So that's what that probability will be. And then the 98th percentile of x. Let's see. So the 98th percentile, in terms of z, it was 2.054. So that means that the z is 2.054. That corresponds from having an x that we don't know minus the mu, which is 15, divided by the standard deviation, which is 3. So if we're going to solve this, the first thing we're going to want to do is multiply both sides by 3. 3 times 2.054, which is actually the answer that I have right there. That is 6.161. That's equal to x minus 15. So then you would add 15 here. And when you do that, you will get an x equivalent to 21.161. So then that would be the X value that would give you the 98th percentile. And again, you could find that directly just using the inverse norm. You can put in 0.98, give it the mean, give it the standard deviation. It'll give you the same thing. That's just doing it in terms of z-scores. Assume that x follows a normal distribution with standard deviation of 8, and that probability that x is less than or equal to 70 is 0.9479. Find the mean. Okay, so basically what we're going to do, this is the probability right here. So a good starting point, we've got x equals, or rather z equals x minus mu all over sigma. And so we can do the inverse normal. We know that the percentile is this probability, 0.9479. For a standard normal, we know that 0 is the mean. We know that 1 is the standard deviation. So the first thing we can do is find the z that will correspond to these values. So what we're going to do is do second vars, do an inverse normal, 0.9479, if I remember right. Yes, 9479. Use 0 for the mean, 1 for the standard deviation. That's going to give you 1.6248. That would be the z that goes with this. 1.6248. Now that we know z and we know x is going to be 70, so we know that 1.6248 should be equivalent to 70 minus a mu that I don't know, divided by a sigma, which is 8. If I'm going to solve this equation, I will need to multiply both sides by 8. Let's find out what that is. So let's take that number times 8. 12.9986. 12.9986. That's equal to 70 minus mu. So then you would subtract 70 from that. Let's see. So subtract 70 from this thing, and you will get negative 57, essentially. So negative 57 is equal to negative mu. That basically means that the mean mu is equal to 57. So there you go. So that way we kind of worked it out a little bit different and found the mean this time. So that is the end of chapter 7.